Hello guys, welcome to Ramta Solutions. Welcome to your grade 12 mathematics. Um, Today in your trigonometry exam prep, we're looking at a question paper from Gauteng province that was written in June of 2024. So because these are past papers, we will begin by reading instruction. We're not going to read all of them, but just a few. Right? So it's important that you guys get used to reading instructions. So um, the first instruction you're going to read is this. Instruction number 3, clearly show all calculations, diagrams, graphs, etc., which you have used in determining your answers. Remember, all. Okay? And then instruction number 4, answers only will not necessarily be awarded full marks. Where necessary, try to show how you got to your answers. Instruction 6, if necessary, round off answers to 2 decimal places unless stated otherwise. Instruction 8, an information sheet with formulas is included at the end of the question paper. In case you forget your formulas, you can always go back to the data sheet at the end of the question paper. And then instruction number 9, write neatly and legibly. It's important, guys, that we improve our handwritings. All right? And before we proceed, if you are using a mobile device, please rotate your screen so you have maximized viewing, right? And we are good to go now. Now, let's go to our exam. Normally, trigonometry is question 5. So let's see. Yes, it's question 5. Okay, it's question 5. So let's see. Okay, 5.1, simplify the following expression without using a calculator. That's 5.1. The expression is, the expression is tan, open bracket, negative x times sine, open bracket, 90 degrees plus x plus sine 2x over 2 cos, open bracket, 360 degrees plus x. All right, tan of negative will be negative tan x. So negative angle of tangent is negative tan x. Sine in the 90 plus quadrant. Which quadrant is that? That is the second quadrant. So sine in that quadrant is positive. But because of the 90, it must change to cosine. So it is cos x. Plus, here, this is a double angle of sine. Sine 2x, we know that it is equal to 2 sine x cos x over 360 plus quadrant. Which quadrant is that? Remember, this x is an acute angle. This is the first quadrant. So cosine in the first quadrant is positive. Therefore, this becomes 2 cos x. All right? Now, your tangent, we know that its identity is sine over cosine. All right? So sine x over cos x multiplied by cos x plus, what do we have here? 2 cos x is cancelling with the 2 cos x. We are left with sine x. Then here, cos x cancels with cos x. We are left with sine x. And then this is negative sine x plus sine x. This is equal to 0. This is equal to 0. Okay, perfect. 5.2, given that sine 27 degrees is equal to p, determine without the use of a calculator each of the following in terms of p. So 5.2.1 cos 27 degrees. So we're going to say, I'm going to draw a triangle here. So it is 27 degrees, 90 degrees. Now these two angles are composite angles, right? Is that what you call them? Yes, that's what we call them. So they are they composite, guys? Okay. Yeah, they complementary angles, not composite. They complementary angles. They add up to 90 degrees, right? So this must be 63 degrees. Now they said sine 27 degrees is P. So sine, we know that it is opposite over hypotenuse. Now, Pythagoras theorem, we know, we will say r squared equals x squared plus y squared. What is r? It's 1. What is x? It's unknown. What is y? It is p. So this then means we have 1 minus p squared equals x squared. Therefore, 1 square root of 1 minus p squared is equal to x. Therefore, this part here is 1 minus p squared. Square root, rather, it is square root of 1 minus p squared. Okay? Perfect. Now, to answer the question, it said we must look for cos 27 degrees. So what is cos 27 degrees? It is square root of 1 minus p squared, isn't it? It is square root of 1 minus p squared. Alright? Perfect. Now, 5.2.2 says we must look for sine square 63 degrees. What is this? We know sine square 63. Did we have a 63? Yes, we did have a 63. Here is it. So sine square 63. Sine 63 will be opposite over hypotenuse. What is this? Aha. So it will be square root of 1 minus p square, then close bracket squared. Now our answer is simply 1 minus p squared. That is your sine square 63. Okay? That is your sine squared 63 or sine 63 squared. Okay? Now, 5.2.3, we are looking for cos 13.15 degrees. 13.15 degrees. What I know is that it seems like it is half of 27, right? It is half of 27. So what I know is this. We can say, since this is cosine, we can say we know cos 27 is equal to 2 cos square 13.5 minus 1. I need to explain this because I think it's important. Remember, we have cos square x equals 2 cos square x minus 1. So cos 2x is equal to 2 cos cos 2x is equal to 2 cos square x minus 1. Alright? So here, if you can see, x is 13.5 degrees. What is 2x? It is 27 degrees. Alright? Alright. So this is what we do. So we have already said we know what cos 27 is. We said it is square root of 1 minus p square. And we don't know what cos 13.5 is. So we're going to leave it like that, isn't it? So we're going to leave it like that. Now let's go to the next. Oh, not to the next page. So what is this? We're going to say square root of 1 minus p squared plus 1 all over 2 cos square 13.5 degrees. Now dividing by 2, we should have done that. We could have done that earlier. All over 2 is equal to cos square 13.5 degrees. Alright? Now, we need a square root of this, isn't it? We need a square root of this. Remember, when you include a square root, this could be positive or negative. But because it's an acute angle, we will ignore it. Okay? Because it's an acute angle, we will just take a positive. All right, acute angle here, I'm referring to it being in the first quadrant, so we'll take the value to be positive. Okay, perfect. So this is our answer. So we are good to go. Remember, guys, we need to be done with this question in 28 minutes. Remember, 1 mark, 1 minute. Right. 5.3. 5.3 says you have cos x plus sin x is equal to k. Express the following in terms of k. So we need to express cos open bracket x minus 45 degrees in terms of k. So what we know, compound angle of cosine, or compound formula of cosine is cos cos. Since it's a minus, it will be cos cos plus sin sine. So this is cos x cos 45 degrees plus sin x sin 45 degrees. Now, what is cos 45? We know it is root 2 over 2 cos x. Again, sin 45, we also know that it is root 2 over 2 sin x. Right? These, even though they say they didn't tell you with or without a calculator, you can just get it directly from your calculator, right? So we can see there's a common factor here, which is root 2 over 2. We are left with cos x plus sin x. Why am I writing k now? Sin x, isn't it? And they said to us cos x plus sin x is k. Therefore, we can conclude and say root 2 over 2 all multiplied by k. That is your answer. Okay, we are good to go. Oh, so we are left with, let's see now, question 5.4 and 5.5. That's 11 marks. Okay, let's see now. 5.4, prove the identity. Let's see, cos 2 theta plus 1 all over sine 2 theta, and then plus tan theta is equal to 1 over sine theta cos theta. The one that seems like is easy to manipulate is the left-hand side. So let's manipulate the left-hand side. So left-hand side is cos 2 theta plus 1 all over sine 2 theta plus tan theta. Okay, so I do see here that in the denominator of the right-hand side, we need sine theta cos theta. So it means we will have to sort of manipulate this guy in a way that we will be working with, maybe use the double angle formula of cosine that has sine, right? So we will then choose 1 minus 2 sine square theta plus 1 all over double angle of sine is 2 sine theta cos theta plus tangent. We know tan theta, its identity is sine theta over cos theta, isn't it? Now, further, let's simplify the numerator here. This is 2 minus 2 sine square theta all over 2 sine theta cos theta plus sine theta over cos theta. Okay, perfect. Now we can see here that we have what I think here it is not lowest common multiple, but lowest common denominator will be 2 sine theta cos theta. Now multiplying throughout, or in fact, when we solve this, this part multiplied by the LCD over the denominator of the fraction, it will be 1. So here we have 2 minus 2 sine square theta plus sine theta LCD divided by the denominator of this fraction. We will be left with 2 sine theta, okay, all over our LCD, which is 2 sine theta cos theta. Okay, all right. So now we have 2 minus 2 sine square theta plus 2 sine square theta all over 2 sine theta cos theta. And this we are left with minus 2 sine theta plus 2 sine theta is 0. So we are left with 2 over 2 sine theta cos theta. Right? Now, as you can see, the 2's will cancel. We will be left with 1 over sine theta cos theta. And this is the right hand side. This is the right hand side. We're good to go. Right? We are good to go. Good. Now, let's see. 5.5. So you see, guys, we have done this a bit faster. Look at us. We are now on about the 16th minute and we need to spend about 28 minutes on this. So this is what you do even in the exam. Okay. All right. So here we have determined the general solution of the equation. That's 5.5. The equation is 4 sine square theta equals cos open bracket 90 degrees minus 2 theta. Right? 90 degrees minus 2 theta. Okay? So what you and I know is this. We know that cos in the 90 minus quadrant, the 90 minus quadrant is the first quadrant, is positive. But because of the 90 degrees, it'll change, it'll become sine 2 theta. Right? Now we are good to go. So this, we know that it is sine square theta minus sine 2 theta equals 0. So please do not confuse these guys. This is sine square, not sine 2, okay? Sine square theta, right? So this then becomes 4 sine square theta minus 2 sine theta cos theta equals 0. There's a common factor here. What is it? Our common factor is 2, right? Our common factor is 2 sine. Am I? Yeah. Oh, yes. Our common factor. Am I lying? No, I'm not. Am I? No, I'm not. Our common factor is 2 sine theta. We are left with 2 sine theta minus cos, let's see, minus cos theta is equal to 0, isn't it? So we have sine theta equals 0 or 2 sine theta equals cos theta. Divide throughout by cos theta, and by 2. It will mean that you have cos tan theta rather is equal to half. Okay, tan theta is equal to half. Okay, great. So for this one, we know that the reference angle here is, let me do this, sine inverse of 0 degrees. It will be 0 degrees. So therefore we can say x is 180, not 180, man. Yeah, 180. I will explain why I'm saying 180. It is 180 degrees k, where k is an element of an integer. The reason I'm saying 180 because it's sine graph. It is like this. Alright? Where do you get 0? You get 0 every 180. This is why I'm content with saying 180. Okay, now let's get here. Our reference angle here is tan inverse of half. What is tan inverse of half? I think it's, oh no, I don't know. Second function times 0.5 will be 26.57. So this is 26.57 degrees. Now we ask, where is tangent positive? It is positive in the first quadrant. So in the first quadrant, we work with x equals reference angle, which is 26.57 degrees, plus 180 degrees k, where k is an element of an integer. Again, where is tangent positive? It is positive in the third quadrant. In the third quadrant. Alright? In the third quadrant. In the third quadrant, what do we work with? We say x is equal to 180 plus. Remember, reduction formula for the third quadrant is 180 plus. So it's 180 plus your reference angle, right, plus 180 degrees k, where k is an element of an integer. So this, I think, is 206,57 degrees plus 180 degrees k. Okay, 180 degrees k, right? You can also, yeah, we good. This is it. So we are done with question 5. Right, we are done with question 5, and check this out. We were done in 20 minutes, so we have saved about 8 minutes. So let's go to the next question. Let's go to the next question. It's question 6. So let's see, how many minutes do we need for question 6? For question 6 we will need about, come on buddy, oh, 13 marks. Okay, no worries. Let's see what they say. In the diagram below, f of x is equal to a sine bx and g of x is equal to 4 cos x are drawn for the interval x, for the interval x is equal to, or rather x is an element of negative 180 degrees included to positive 180 degrees included. The graph of f of x passes through 90 degrees and 5, and the point of g of, oh, and the graph of g of x passes through 90 and 0. G of x passes through 90 and 0. Where is that? G of x, which one is, okay, here is it, 90 and 0. And by the way, guys, remember, if you watching this video using a mobile device, please rotate your screen. Okay, through 90 and 0, I can see it. A and B are points of intersection of the graphs of f and g. A has coordinates negative 141,34 degrees and negative 3,12. All right, cool. Determine the values of A and B. So 6.1, A and B, they belong to sine graph. A represents amplitude, which is 4. Right, so is it 4? No, no, no. That's f of x. Which one is f of x? Okay, this one here. So A is 5. And then what is B? B, B, let's see, B should be 1. B should be 1, as you can see, because check the period here, right? Should I say the period? Yeah, the period is 360. Can you see that? The period is 360, so B must be 1, right? B is 1, okay? B is 1. This is why this is 2 marks, okay? This is why this is 2 marks, okay? If you want to know how we determine that, we say, okay, half cycle is 180 degrees. Another cycle is 180 degrees. So one cycle can be completed in 360 degrees. So then our B is 1, which is the coefficient of x. Okay, 6.2, the graph of f of x is shifted. Oh, the graph of f of x is shifted 30 degrees to the right and 2 units vertically down to form the graph h of x. So h of x is g of x shifted 30 degrees to the right. So this will be minus 30 degrees. And then 2 units downwards. So it's minus 2. Determine the equation of g of x. On of h of x, rather. On g of x, where does x, we put x minus 30. So this is all cos x minus 30 degrees minus 2. That's it. We are done. Okay, perfect. 6.3. 6.3, we'll have to explain this. So 6.3, let's say we have, I'm going to say 8, 6, 4, 2. Okay. Yeah, okay, let me restart. restart. Okay, and then 0, and then we have 30, 60, 90, but negatives. Okay, 30, 60, 90, but these are positives. All right, so we have a line here. They say calculate the minimum value of this guy. It's this one here. Okay, and then we have g of x, which one is there, and then we have g of x at 60 to whatever. I'm just gonna say 60 to 4, and then it's gonna be like this. Right, it's gonna be negative 60. Oops, no, negative 60, it's positive 2. Okay, and positive so it's gonna be like this. So they have restricted us that we must look at negative 60. Here is it. All right, here is it. This is negative 60, positive 60. So the minimum value that we have here is not, it's tempting to think that the minimum is negative 4. Okay, so it is not negative 4. The minimum for G will be positive 2. Okay, so now to answer this question, minimum value is 8 over, what is the minimum of g of x in this domain? It is 2. In the domain they gave us, here is it. It is 2. Therefore, our answer is 4. It is tempting, guys, to think that the minimum value will be divided by 4, will be 8 divided by 4, because the minimum of this g of x is negative 4. It is not in this case. In this case, it is positive 2. Okay, so your answer is 4. Okay, I know others are expecting negative 2 or 2. All right, it is not that. All right, 6.4. If A has coordinates negative 141,34 degrees and negative 3,12, determine the coordinates of B. They are easily, x of B will be negative 141,34 degrees plus 180 degrees. What is this? This must be 38,66 degrees. Okay, you guys have calculators, but for me, I don't like destroying my batteries with such. Okay, all right, guys. Now, y of b is a matter of saying it is negative of y of a. Okay, it is a reflection in the x-axis, so it is negative of y of a, which is negative times negative 3,12, which is 3 comma positive 3,12. Therefore we can say b is 38.66 degrees and 3.12. This value, by the way, you can also get it by substituting 38,66 into either f of x or g of x. Okay, perfect. Now 6.5. For which values of k will f of x not have solutions or have no real solutions? Let's see. F of x equals k. What is f of x? F of x, I think we said it was 5 sine x equals k. Okay, so as you can see, for it to have real solutions, honestly speaking, this is when k is the amplitude, when k is positive 5, or when k is, or rather when k is between negative 5 and positive 5. This is when it'll have real solutions. But to not have real solutions, okay, to not have real solutions, so no solutions at all, to not have real solutions, 5 sine x must be greater than positive 5, or 5 sine x must be less than -5. Remember the minimum was -5. But what is 5 sine x? We said it is k. So k must be greater than 5 or k must be less than -5. So any value that is less than -5, it will not give you a solution. And any value that is greater than 5 will not give you a solution. Okay, this is how we answer this question. Okay, guys, remember, for you to get solutions, k must be between -5 and +5. If it's below -5, trust me, you won't get a solution. If it's above +5, you won't get a solution as well. Okay, perfect. Now, I'm sorry this question has this particular question I don't like. I will show you, but 6.1 is easy. They say in this domain that we are given, f of x is less than g of x. When you look at this, we are saying f of x should be below g of x. Which region is that? So you now need to refer to or look at points of intersections. Okay, points of intersections will be a great start. So to the left of this point of intersection, let's see, f of x, can you see it? F of x is above g of x. That's not what we are looking for, so we ignore it. But to the right of this point until at point B, look at this. F of x is below g of x. Do you see that? F of x is below g of x. So what is the x value here? So here we'll say this is when x is greater than -141,34 degrees, but less than, what was the x value for B? It was 38.66. Let me go check it out. Let's go up. Okay, 38.66, correct. All right, this is you now answering this question. Now 6.6.2, I don't like what they did here, guys. I really don't like what they did here. F prime x, let me begin by saying f of x, you guys haven't done this as yet. F of x is, or let me begin by saying this. When y is sine x, y prime is cos x. When y is cos x, or let me call it g, g prime will be negative sine x. Okay, this is a tip. You're gonna learn about this topic later on after Euclidean geometry. In fact, 3 topics later after this. Okay, it's called differentiation calculus, but you don't do these functions. Okay, so f of x, if you recall, f of x was 5 sine x. So f prime x will be 5 cos x. Okay, now I want to plot it. So to show you, I want to plot it. So let's say we have 180. I'm gonna say 90, and then I'm gonna leave it. Okay, 2, 4, 6, much better. And then I'm gonna say, oh wait. And then it's gonna be 90, 180. It's gonna be 90, 180. You are 0, 0. You are 0. You are you are 2. You are 4. You are 6. Right? So we had, if you recall, now f prime x is 5, maximum is 5, so it's gonna be like this, it won't change. Okay, it's gonna be like this, it won't change. So this is your, oops. Okay, much better. This is gonna be your, f prime. Okay, this is gonna be your f prime. I'm gonna change the color to show you the other one. Its maximum is 4. Remember, 4. Its maximum is 4. All right, its maximum is 4. Okay, it's 4. Do you guys see it? So this one was G. Do you see it? So this one here says the product of G of x and f prime x must be 0 or equal to or positive, sorry. So what does it mean? Both of them must be negative, or both of them must be positive, or one or both must be 0. So for this, we're not even going to waste our time. We can just say simply the domain S is negative x is an element of negative 180 degrees included to positive 180 degrees included. Or if you like, you can say this is when x is greater or equal to negative 180 degrees, but less or equal to positive 180 degrees. Why are we saying that? Remember I said here we are saying when f prime x is positive, when f prime x is positive, g prime x must also be positive. When f prime x is negative, g prime x must also be negative. Or one or both can be 0 as well. And this is the case for the whole domain, right? Exactly. So we are done. Let's now head to the the last question, which is question what? Question 7, I believe. Um, I believe we took longer in the last question. Question 6. Now it's question 7. In the diagram below, TQR represents 3 points in a horizontal plane on a sports field. Okay, on a sports field. PQ represents a vertical pole, okay, a vertical flat pole, and then the angle of elevation of the top of the pole from R is theta. Angle T is theta. TQ is equal to TR. They are all equal to Y. QR is equal to X units, and then angle TQR is equal to alpha. I can see it. Okay. 7.1, they say show that sine alpha, express theta in terms of alpha, and show that sine theta is equal to sine 2 alpha. So we can say in triangle TQR, you will agree with me. Oh, I said triangle, but I'm not writing it. In triangle TQR, you can say theta, or maybe I shouldn't say it. Yeah, theta is equal to 180 degrees minus, or maybe that is not right. Let me write it in this way. Angle T is equal to 180 degrees minus angle Q minus angle R, right? So before we proceed, we can say this is 180 degrees minus alpha minus alpha. So this is 180 degrees minus 2 alpha. The reason I'm saying that is because angle R is equal to angle Q because they are angles opposite equal sides. Okay? Therefore, sine theta is equal to sine, what is theta? We said theta is 180 minus 2 alpha. So sine theta is equal to sine 2 alpha. Okay, perfect. Because this is a reduction formula, sine is positive in the 180 minus quadrant. Okay, let's go. 7.2, prove that in triangle PQR, PR, where's PR? Okay, I can see. Oh, it's this one. PR is equal to 2y cos alpha. Oh, interesting. 2y cos alpha over cos theta. An interesting one. But it's an interesting one. Very interesting. So now, what we are going to do now is this. We're going to say we need sine rule first. So, but why 4 marks? But it's okay. We can take it. Right? We can take it. So I will say again, in triangle TQR, I will need to find this x in terms of theta. Okay? So I'm going to say x over which side is opposite x? its angle t. So this is x over sine theta is equal to, I will take y. Which y am I taking? I'm taking this one here, tr over which side, which angle is opposite it? Angle q, which is sine alpha. Okay, so x equals y sine theta over sine alpha. We did say that sine theta is equal to sine 2 alpha, isn't it? Now, this, as you can see, is a double angle. Now, since it's a double angle, this will mean we are saying this is 2y sine alpha cos alpha all over sine alpha. Okay? Proceeding, this therefore means x is 2y cos alpha. This is the value of x, right? Proceeding, now we say in triangle PQR, in triangle PQR, we can see we are looking for PR. PR is the hypotenuse, and we have this side here, which is the adjacent to this angle theta. Okay, so what do we say? We're going to say adjacent and hypotenuse is cosine. So cos theta is equal to adjacent is x. What is the hypotenuse? Hypotenuse is PR. All right, we are looking for PR, by the way. So PR is equal to x over cos theta. Okay, moving on. What is x? We said it is 2y cos alpha. So we were able to prove this. Happy? Good. We're able to prove this. We are good. 7.3. If A is 49 degrees, X is 20 meters, and Y is 15 meters, calculate the area of triangle PQR. So, no worries. We're looking at PQR. We know that area of triangle PQR is equal to half times, I'm going to say half times TQ times QR times sine angle TQR. Let me just say angle TQR for now. Okay, so what is this? This is half times, what is TQ? TQ is Y. What is QR? It's X times sine angle alpha. Sine alpha, isn't it? So this, what is Y? They said Y is 15, and they say X is 20 times sine 49 degrees. So on calculator, I will say we have 10 times 15. I should have said 150. 10 times 15 times sine 49. What is our answer? Our answer is 113.21 square meters. That is the area of triangle TQR. What? Oh, triangle TQR. What did I say now? PQR. Here. TQR. Sorry, guys. TQR. Okay, of triangle TQR. So this is it. We have come to the end of our lesson. Remember, guys, if you have come to this point, it means you are enjoying this, and would appreciate if you like the video. And of course, if you want to comment if you have questions, and please subscribe and share the video with your classmates and other people in your circles. Right? And if you would like to follow us on your social media platforms, you can check us out on the links given in the description of this video, or there will be links of different social media platforms, right? All right. So with that being said, ours ends here, and bye bye.